Hello, everyone. My name is Christine Jameson, and I will be your host for today's webinar. I am the Global Marketing Specialist here at Clean Energy Compression. This webinar will run approximately 1 hour with 45 minutes of speaking and a 15-minute question and answer period at the end. You're welcome to ask a question anytime during the webinar. To do this, simply type a question into the side panel where it says questions, and we'll get to your question at the end of the webinar. Our speaker today is Brad Niels. Brad Niels has a Bachelor's of Applied Science in Mechanical Engineering from the University of British Columbia. He has worked at Clean Energy Compression for over 7 years, starting as a design engineer and now working as an applications engineer. Over to you, Brad.
Thanks, Christine, and good day, everybody. In today's presentation, I'll be going over the new CleanCNG standard design, and I will be pointing out a number of the service aspects that have been improved on the new design, and towards the end of the presentation we will show a rough estimate of some of the savings in dollars that can be associated with each of these improvements. So what is the new CleanCNG? A picture is shown here. It's a new standard model for clean energy compression that is based on a modular approach. So standard modules can be ordered very simply and are available with quick lead times. They've been pre-engineered and designed, and every time we build another one, we have another validated design that can be offered again the next time easily. This new design has much lower vibration than some of the previous models. In fact, vibration is so low that we have run several tests with a Canadian $1 coin balanced on edge on one of the scrubber bottles, and it kept standing even with compressor running unanchored on gravel. This new design also has improved tubing and piping access, which has led to reduced interstage pressure drops, and all of these have led to lower oil carryover and cleaner gas exiting the package. Finally, this package is a modular package that can be added later on to existing installations. So for example, if there's one compressor package on site, a second one can be added in the future side by side to create a compact twin package. Some of the aspects of the new design, as I mentioned, it's a single package footprint that can be installed side by side to form twin, triple, quad. Recently we've even seen a designer incorporating our design to create a 6 compressor installation all side by side for the lowest footprint available. Serviceability on the major components has been greatly increased with the CBA, the heat exchangers, the recovery tank, the motor, etc., all easily accessible from outside the skid to improve and service of all of those components as necessary. The new package fits into a normal 20-foot shipping container for reduced shipping costs. The frame is a box frame which greatly strengthens the skid and enclosure frame, giving a lot of extra rigidity, and that has greatly helped to reduce the vibration of the package. We use the same package for the entire horsepower range of 100 to 300 horsepower. All of the major assemblies and components remain modular. The same heat exchanger assembly frame is used each time, the same skid, the same recovery tank stand, etc. So those components can be mass-produced and bolted in. The design has been approached from the aspect of design for manufacture, and this has reduced the human error in the assembly process, as well as reducing the labor hours required to assemble a complete compressor package. The cooling air can be discharged either out the side of the compressor package or up into the air, depending on the preference. The modules bolt onto the skid, which reduces the welding required at the final assembly stage. And we've also been able to, because of the standardization process, hone in on the design of the components and do some finite element analysis calculations to ensure that all of those components are suitable for the entire range. This here is a rendering of what a twin package would look like. There's two packages that ship individually to the site. On site they are mounted with about a 6-inch space between them. We ship a bridging kit loose to site that is installed on site that covers up the gap, and it looks like a twin package side by side. So some of the reasons why this new package is better are the serviceability, lower vibration and noise, and reduced oil carryover. We had one of our senior technicians integrally involved with the design work and ensured that the new package was as serviceable as possible in order to make life easier for technicians and those people working with and on the equipment. One of the major features is an internal service corridor. As you can see on this slide, there's a model of a human inside the compressor package. The access is on the top left of the package, and the service technician or operator can walk in the front door and have access right inside the package to all of the major service components. This greatly helps with the weekly, monthly, and yearly maintenance intervals. They're much simpler to perform and much more likely to occur because of the ease of access to those service components. So I'll just go over a number of the improvements on the service side. So the first one is this 360-degree visual inspection on the compressor block and filter and drain access. So the compressor block has nearly 360-degree access all around it. The front is completely accessible by opening the air inlet louvers. Are accessible directly from outside of the compressor package via the access panels or by walking in the internal corridor. There's no more reaching in to the package, having to strain to reach the drains, and potentially missing drains during the weekly or monthly service intervals. In addition, the filter element is directly accessible and can be replaced on a regular basis without having to crawl inside the compressor package in an uncomfortable position. The next item is a centralized drain location and oil site. As can be seen on the lower photo on your screen, there's a curved 2-inch piece of pipe that has a number of drain hoses going into it with a drain hose on the bottom. That is the centralized drain location for all of the scrubber bottles and filters, so any moisture that works its way into the package or into the filter bowl can be drained into that header, and then a small 1/4-inch ball valve on the bottom of the header, easily accessible from the inside of the package, can be used to drain into a container for disposal. In addition, on the right-hand side of the compressor block, there's that black item, which is the oil sight glass. That shows the level of the oil inside the crankcase. It is easily accessible, again, very visible, and allows the operator to keep a much better eye on the oil level, which allows the oil to be topped up on a regular basis as needed and provides much greater visibility. rather than having to crawl inside the package to check the oil level. The next item is indicator taps on all of the head and crank end of this compression cylinders. As you can see on the top right-hand photo, those ports are just plugged. There's a small 1/4-inch plug on the compressor cylinder that can be removed and instrumentation added to that location for troubleshooting in case of any issues or reduced performance. And that can help monitor the performance of each of the stages to assist with troubleshooting ring wear, valve malfunction, and any other issues with the cylinder that may be causing reduced performance. We have included a recovery tank isolation valve that is installed between the recovery tank and recovery tank relief valve. It comes with a lock and is locked in the open position during normal operation. Only during maintenance requirement on the relief valve would this valve be closed, and that allows the gas to be maintained inside of the inside of the recovery tank, which allows that gas to be saved rather than vented to atmosphere during maintenance. It also speeds up the service time because the service technician no longer needs to wait for the entire system to drain down in order to access that relief valve. And then one of the most exciting aspects is this overhead crane shown on the bottom right hand of your screen. The yellow portion of the two yellow sections shown there are the crane. These two sections lock together or can be decoupled in order to get almost complete access to all of the major components for service as needed. This crane can be used to, for example, remove the main motor sheave, the compressor sheave, the fan motors, etc., and is really helpful with removing those components and taking them to the edge of the skid. Two 2-foot fluorescent fixtures installed inside the package to provide light to all of the areas where service is required. With regards to the electrical box is now installed inside the compressor package and is accessible from the service corridor. This allows technicians to do maintenance and service on the electrical components from inside the compressor package, even in inclement weather such as rain, where previously that would be required from outside the package, requiring tents or requiring or allowing moisture into the panel. The heat exchangers are much more accessible on the new design. As shown on the left-hand side on the model, the heat exchangers are mounted horizontally. The airflow moves through the heat exchangers horizontally and then is either ducted upwards or outwards, depending on the customer preference. These heat exchangers are accessible via the discharge louvers, which again swing open with a door handle and are hinged on the outsides. This allows the operator to easily inspect the heat exchangers for fouling and slide out a single heat exchanger from the side of the package in case of heat exchanger failure or replacement required. The connections are also easily undone with flange connections, and the whole heat exchanger can be removed very easily without requiring a heavy crane to access the heat exchanger from the top of the package. The pressure safety valves have all been relocated into an area easily accessible by a service technician. As shown on the right-hand side of the screen, they are mounted to a central vent header, and the view shown here is directly inside a door that can be opened, granting access to all of the relief valves from one location. from outside the package without having to crawl inside the package and access the relief valves that way. A motor, service rail, and frame provisions have been built into the package so that the main motor can easily be removed. The rail and frame do not fit the compressor but can be purchased as a separate item, such that in the unlikely event of a motor fit, system can be inserted into a holder that's built into the compressor package, and then the crane used to slide on that rail attached to the main motor as shown, and the motor can be removed out through one of the doors. In fact, the same door that the relief valves are accessible via. And finally, the control gas regulator has been relocated at the end of the service corridor for ease of access, and in addition, a transmitter has been added to the system such that the control gas pressure can be monitored. Warnings and alarms can be triggered based on high and low control gas pressure for immediate access and easy troubleshooting of loss of pressure if required. This slide shows a number of calculations that have been associated with each of the service items that I went through on the previous slides. A number of assumptions were required to come up with these numbers, and this is not intended to be a comprehensive analysis of all of the savings. However, it's meant primarily to provide an indication of a ballpark value associated with the improvements that have been made. So a number of assumptions have been made on the time savings that each of these aspects present. A value of $65 per hour has been assigned to each of those hours, and a lifetime of 25 years of the compressor package has been assumed. In addition, downtime savings have been estimated at $300 per hour, and when put all together, these savings could add up to approximately $500,000 over the lifetime of the compressor. Now, a number of the assumptions and details of these calculations can be sent out to all of the attendees in a couple of weeks once they are finalized, and that will provide a little more detail as well as to all of these aspects and savings associated with them. As mentioned earlier, the new package has a much lower design noise level compared to some of previous packages. Testing on one 250 horsepower package here at the factory showed that we were able to achieve lower than 75 decibels A-weighted at 3 meters, which is very low, and particularly compared to some of our previous designs and many of our competitors. This slide shows a number of test results on a 250 horsepower 5-stage compressor built and tested here at the factory. A number of different areas were tested for vibration levels. As you can see, the maximum vibration level achieved in any location on the package was below 0.8 inches per second peak-to-peak vibration velocity. Typically, the cutoff for vibration is 1.2 inches per second, and in all cases we're much, much lower than that cutoff. These test results were taken on the compressor package when it was mounted on a gravel pad, unanchored, and would be expected to be even lower when properly installed on-site, bolted down to a concrete pad and installed properly. And there is a video available at on YouTube that shows the coin test of the Canadian dollar coin standing on top of a scrubber bottle with the compressor running, and the vibration is not high enough to flip that coin over. This slide shows a number of the noise levels that were measured on the compressor package built and tested here at the factory, with a background noise of 68 decibels. At several measurements are shown here at 1 meter and 3 meter distances from the package. In all cases, the noise level is lower than the compressor blocks have always been non-lubricated, but the improvements here have even improved that performance because of the lower vibration. This here is a photo of the compressor package from the front with the air inlet louvers open. This is a 5-stage compressor with all of the piping, bottles, valves, etc. attached. Just gives you an overview of what the package looks like with the fans, cooling fans in the background on the right-hand side of the package. This slide shows a number of the technical specifications for the standard range. The size and weight of the package remain fairly consistent throughout the design range, as the same skid is used each time. There's gas line connections can either be 2-inch or 3-inch. The electrical classification, Class 1 Div 1 or Class 1 Div 2. The MCC panels are non-hazardous and would be installed remotely from the compressor package outside of the hazardous area. The main motor power standard offerings are 150, 250, and 300 horsepower, with 100 and 200 horsepower versions optional. The voltage and electrical requirements are 50 or 60 hertz and 380 to 600 volts. The priority panel is available on skid for the international market and off skid for the North American market. Several of the codes we comply to. The elevation that we've designed these units for is 0 to 2,000 meters. Higher elevations are possible but would need to be evaluated first. Ambient range in the range of -40 to 45 degrees Celsius is possible, and higher if required. These are the standard specs. And this just shows you some of the flow curves for the operating envelopes for the standard range. Standard range here is shown up to 100 psi, but we have extended range models that go up to 1,000 psi and definitely are able to accommodate different pressure ranges. So that's all I've got. Actually went through that quicker than expected, which gives us a little more time for questions if there are any. So Christine, I don't know if you've gotten some questions.
Awesome. Thank you, Brad. Okay, so I see lots of questions coming in, so I think we're going to start going through these. The first question is, how about CE approvals?
So CE approvals are currently in process. So at this moment, the CleanCNG standard package does not have CE approval, but our design team is working on those as we speak, and they are expected to be available later this year.
Okay, Brad. And do you know what pricing is expected to be?
There are a lot of factors involved on the pricing. So we would need to look at the particular application, and we'd have to get back to you. So if you send us an inquiry with sort of the flow rates, horsepower, pressures, that sort of thing, we'd be able to get you a price fairly quickly.
Okay, the next question I can actually answer for you. Is there a benefits and features handout? So we actually just completed a brand new brochure that goes over the features and benefits of this unit, and it is available in a digital version at the moment, and will be available in a hard copy version within the next few weeks. It will be available for download off of the website in about a week. If you would like a hard copy of the, if you'd like a copy sent to you, please contact me directly. And next question for you, Brad. What is the cost to add the rail to remove the motor?
That I don't have the exact price in front of me, but I believe it's in the order of about $3,000.
How does vibration factor into reliability?
That's a great question. In fact, vibration is one of the biggest killers on rotating equipment and moving equipment because it essentially leads to premature failure of components. It increases the fatigue failure frequency or requires additional stronger components. In addition, internal to the compressor block itself, there's a lot of rattling going on, which can reduce the ring life. It can also reduce the efficiency of the oil wiper rings, which allows additional oil to make way into the compressed natural gas, which is a big no-no, as well as just creating a lot of stress on all of the components. So what we tend to see in that case is premature failing of the rings, potentially the compressor valves, and in extreme cases even of the piston rods. And sometimes piping can become loose, so a lot of the piping fittings may need to be made up on a more regular basis. So lowering the vibration really reduces the service requirements as well as the replacement frequency of major components.
Okay, awesome. How does our vibration analysis compare to aerial?
I don't have that information directly in front of me. Again, it would depend on the size of the units and the particular configurations. The aerial does have the opposed, I can't think of the word right now, but the two wings are directly opposed from each other, which increases the balance inherently. But with our three-throw design and with some of these improvements that have been made, I believe we're in the same ballpark as them. I'd have to look into that a little deeper and get back to you.
So while we are on the topic of aerial, how does noise level compare to aerial?
So that's a difficult one because aerial builds the compressor blocks, and the primary source of noise on a compressor package is from the cooling fans. So in fact, comparing to aerial really would provide a lot of good information because the compressor block to compressor block to noise level almost makes no difference. So primarily we'd be looking at the packagers and the fans that they use and the design of the enclosures and cooling path, which contributes primarily to the noise level.
Great. Now, we touched on this a little bit before, but have these changes reduced the cost of the compressor package?
They have in the aspect of reducing the engineering required on each package. And so what that means is that lower non-recurring engineering is required per package, and so that is directly savings that can be passed on to the customer. Now there are a lot of other contributing factors to the price of the compressors, such as material costs, exchange rate, and all of those items. So while the savings have reduced several aspects of the cost, there may be other factors that have increased the price, and so on balance we'd have to take a look at it but I believe it's about the same ballpark.
Okay, now I have a few technical questions coming in here. The package has a weight of 7.7 tons. It is 2 tons more than the previous model. What is the main reason for this increase?
Sure. And again, that 7.7 tons is a ballpark estimate for some of the packages. Of course, the smaller packages will be lighter. 100 horsepower unit will be lighter than a 300 horsepower unit. Also, some of the previous estimates of the weight of the packages may not have been as high as they actually were in reality, based on better prediction models that we're able to use with the standardized model. But primarily the increase is a beefier skid and a heavier frame, and additional bracing. So what this means, this has contributed to the rigidity, reduced the vibration, but increases the mass.
And does vibration increase when you're adding more units?
No, the vibration would not increase. The units are designed such that they sit adjacent to each other, but there is a gap between them, and therefore there's no transfer of vibration from one unit to another. So the problem of harmonics based on the two units operating slightly out of phase to each other has been eliminated in the new design.
Okay. What are the kilowatts of the fan motors? Previously had 2 times 4 kilowatt motors, which created 96 dBA in 1 meter. What are the kilowatts of these motors?
The kilowatts of the motors are the same. So these would still be 2 4 kilowatt motors or 5 horsepower motors. Again, different packages might use different fan configurations. So we have 3 different offerings. There's the 2 times 4 kilowatt or 5 horsepower motors is the most common. On some of the higher flow units, we need some additional cooling, so we've gone to a 7.5 horsepower or 5.5 kilowatt. And on the highest flow configurations, we may be using 4 kilowatt motors. Now, the primary benefit on the new design is the fans themselves have been selected. They're the lowest noise fans that we're able to find with our vendor. And as well, the enclosure design has been improved to reduce the noise level that's transmitted to the outside. So the combination of the fan and the enclosure design are the primary reasons for reducing the noise level, even while the horsepower of the fan motors has not changed. In areas where the design is 100% complete, lead times for standard product can be as low as 14 to 16 weeks, and we're even working on improving that. So there are still some designs in the international markets that are being worked on, which will increase the lead time at this point in time, but that again would reduce towards the end of this year as those designs get completed.
Okay. Have these changes extended the life of the compressor?
It's a little bit hard to point because the new design has only been operational for about a year. But because of the factors that have been mentioned, which are the primary reasons for causing failure, we're very optimistic that this will improve the lead and the lifetime of these units.
Do other compressor packages have the motor removal rail, or is it just CEC?
As far as we know, the this is unique to us, but due to the large number of manufacturers out there, it's possible that some of them have this feature as well.
Gas utility companies typically ask us how much flow/volume our stations will require. Do you have a chart graph available that we can provide them to show them our needs for each compressor while it's in operation?
Yes. Now, the flow rate is very dependent on the site conditions. So the inlet pressure, the horsepower of the unit, and the required flow, as well as the number of units that would be on site, are all contributing factors. So we'd have to look at this on a site-by-site basis to give you that number, but it's very easy to come up with.
Is this unit also available without an enclosure?
We are currently offering this unit without an enclosure. Some things to keep in mind, though, are the noise level will increase, because as I mentioned, the enclosure has been designed to reduce the noise level. Then we would keep the main access door attached on the skid, even though none of the other enclosure panels will be present. And that is because there's an operator interface on that door with lights and switches that would still need to be provided even without an enclosure.
So I have more questions coming in about lead time. Do you know what the general lead time is in weeks for the U.S.?
Right now the U.S. is about 14 to 16 weeks. Again, depending on if that's a standard model and depending on our production load at the time. But that's the current lead time that we're quoting.
Okay. Do Angie, JW Power, or other prominent packagers have a standard overhead crane? Ours is standard, right?
Ours is standard in the North American market and optional in the international markets. International markets that are more cost sensitive may not be willing to pay for that feature, and so it's included as an optional feature. As far as I know, those other manufacturers do not have the overhead crane, but I'm not as familiar with JW Power. They may. I can't answer that one conclusively.
Okay, just a few more questions here. Since the vibration reduced, the weight increased, do we need more strong ground for assembling?
Sorry, can you repeat the last sentence?
Since a vibration is reduced but the weight is increased, do we need stronger ground for assembling?
We have a recommended concrete pad installation that comes with the general arrangement drawing that we can send to you. But the pad is intended to be about 2 to 3 times the mass of the package itself. So yes, the pad would need to be a little larger, a little beefier to accommodate that.
Okay, one last question. How do you reduce the noise in the package?
Okay, so as I mentioned, the primary source of noise is the cooling fan motors. So several manufacturers, they can offer a reduced noise, low profile fan blade, so it disturbs the air less as it moves through, and that reduces the level of noise that's being created at the fan itself. Now, there's a limit as to how low you can go with that, because in general, the trade-off is reduced airflow. So the secondary way that we've approached this is with the louver design and the enclosure package design. So we've increased the amount of acoustic insulation inside the package, and so that absorbs some of the noise. And in addition, we've changed the airflow path of the air, and that removes the direct line of sight from the compressor package internals to the outside. And so again, that reduces the level of noise that a person standing outside the package would hear, because less of those noise waves are making their way out of the package.
Great. So it looks like that's all the questions that we have. Thank you all for your time. We're going to wrap it up there. If you have any questions, you can always contact us directly. Thank you. Have a great day.